Okay, let's look at lesson 94, direct variation number 1. Now, in the previous lesson, we looked at indirect variation, and that probably should have come after linear functions. But I decided to put it before we really got into linear functions because the next 20 or 30 videos are going to concentrate strictly on linear functions. And so since we introduced what linear functions look like, then we talked about quadratics and nonlinear functions, I threw inverse variation in there. So let's get into it. Here's our objective, vocabulary. Remember, an ordered pair has two numbers. And this is very important. When you see a point, you're talking about two numbers inside a parenthesis separated by a comma. And you want to make sure that you identify that as a point. So pause these slides, read over the words and objective. Direct variation, y equals kx. And when we were talking about inverse variation or indirect variation, the x was on the bottom. So this is the same setup. Y and x are our variables. X is independent, y is dependent, but k is a constant. Now, when we're talking about direct variation, the graph must go through the point 0, 0. That's the most important thing about direct variation. Okay, does the table show direct variation? So basically, what you do is you divide. So your y equals kx. If you want to solve for k, so let's put y equals kx. To solve for k, you have to divide both sides by x. And now you're looking at k equals y over x. And when you divide 615 by 205, you get 3. When you divide 930 by 310, you get 3. 510 divided by 170, you get 3. So this table does show direct variation. Okay, Brian P as a lifeguard varies directly as his number of working hours H. So they're telling you that this is a direct variation. Pay equals some constant times H. If Brian's pay for 12 hours is $102, so they tell you that 12 hours, 12 goes here, 102 goes here. So now we got to find K, and then we substitute that in for, so 102 equals K times 12. Divide both sides by 12, and then some number. $8.5 equals K. So Brian makes $8.50 an hour. So how much is his pay for 37 hours? So his pay equals 8.5 times 37. And Brian's pay will be 314.5, which is $314.50, because you can make $0.5, but we don't refer to it that way. So those were our two examples. Please use your equation, y equals kx, and work on the practice problems, and I will see you at the end of the video for a review. Okay, so find the equation of direct variation when y equals 21 and x equals 1.5. So we're going to use y equals kx. We're going to substitute 21 equals k times 1.5. Divide both sides by 1.5. And then 21 divided by 1.5 equals 14 is k. So now we come back to our general equation. Y equals 14x. Okay, so if I went a little fast through that equation solving, please go back to my earlier videos on solving equations. I have about 20 to 25 videos on solving different types of equations that you can check through where the pace is a little slower. But since you're with me up here, I will assume that you work through solving equations and you've attained mastery over that. Okay, so now this is an odd table. Distance and time. 9 times out of 10, your x will be on the top. But like I said, time most times will be x, and the distance is an output, so that's your y. So these are a little backwards. So what's on top is what's to be divided. So you're going to do 90 divided by 3, 120 divided by 4, 150 divided by 5, and 180 divided by 6. And you can all see that comes out to 30. So that shows direct variation. And then consider an equation where y blah, 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 blah. All right, so we're going to find k first. Y equals kx. We're going to substitute in 109.56 equals k times 8.3. Divide both sides by 8.3. 109.56 divided by 8.3 equals 13.2. Now, find the value of y when x equals 2.2. So let's do that. Y equals 13.2. As always, I'm still substituting with parentheses. Times 2.2 gives us 29.04. So there you go. That's basic direct variation. There is a part 2 to this video, so please watch both videos. And thank you for watching. If you like what you saw, please subscribe to this channel. And I will hope to see you on the next video.